Right, greetings mathematicians. I am making this video because I know systems of equations is it can be a very confusing concept, and especially with distance learning, I wasn't able to cover all of the things about systems of equations that I would have liked to had we been in school. So I just want to walk you guys through a few examples using each of the methods for solving systems. Okay, and these are all going to come from the worksheets that were assigned this week. So, first one I'm going to look at is the solving systems of equations by elimination worksheet. Okay, so make sure you're on the right worksheet here. I'm going to work through the examples, or the problems 11, and 23 was also a tricky one. Okay, so with that, let's get right into it. So, using elimination, remember our goal here is to get rid of one of the variables right off the bat, right? And with an example like, say, like number 7, really quick, you'll notice that, or no, not number 7, let's look at, you'll notice in an example like, well, let's just go back to number 1. Like number 1, right off the bat, you'll notice, hey, the x's look like they can cancel each other out. I have a -4 and I have a +4, right? The coefficients are the opposites of one another. That makes it really easy to eliminate a variable. But in the case of number 11, we don't have that here. Actually, none of the coefficients match here. So what we can do is we can actually change these numbers here. We can change these things so that they match each other. What I see is that this -3 can be turned into a -9, or I could even make it a +9 if I really wanted to. So what I'm going to do is I'm going to take this, so I'm going to work up here. So I'm going to take this equation, -3x plus 7y is equal to -16, and I want to change that into, let's make it a +9, so that way we already have the elimination set up. So in order to make -3 +9, I need to multiply this by -3. So how am I going to write this? I'm going to say I'm going to multiply that by -3. If I do it to the left side, I also have to do it to the right side. Did anyone catch my mistake yet? Did anyone catch it? Please tell me you caught it. Okay, I'll tell you. This right here, I cannot just multiply -3x times -3, because if you think about it, I'm multiplying the right side of my equation by -3. I also need to multiply the left side of my equation by -3. And is -3x the only thing on the left side of my equation? No, it is not. I need to multiply it, or I need to multiply this 7y times -3 as well. So I'll rewrite this to look something like this. And there we go. That looks much better. So let's go ahead and multiply. So -3 times -3x is +9x. -3 times 7y is -21y. And then -16 times -3 is +48. And there we have a nice equation. So what I'm just going to do is I'm going to rewrite it underneath here. So now I have 9x minus 21y is equal to 48. And now I have an equation that I can, or a system of equations, excuse me, where I can easily eliminate one of the variables. And I'll highlight it here. I can eliminate this -9x with this +9x here. So to eliminate them, I'm going to add them together. I'm going to add the left sides of my equations together, and I'm going to add the right sides of my equations together. So let's go ahead and do that. And of course, we can ignore this top equation now because I changed it into this one, right? So you don't even need to worry about it. Alright, so the x's cancel each other out, so we're left with nothing there. 5y plus -21y is -16y, and that is equal to 16 plus 48 is 64. And then we go ahead and solve for y. So I'm going to divide both sides by negative 16, excuse me. So y is equal to negative 4. And there we go. Okay, so what I'm going to do now is I'm going to take this y value and plug it in for y in one of the equations. So I'm going to write in blue here. So I'm going to plug it into the equation negative 9x plus 5y equals 16. But instead of writing 5y, I plug in my negative 4. And then I solve for x. So now I have negative 9x plus 20 is equal to 16. Subtract 20 from both sides. And I get negative 9x is equal to, I believe that is negative 4. I divide both sides by negative 9. X is equal to negative 4 divided by negative 9 would give me positive 4/9. Okay, let me double check my answer here really quick. So fortunately we have an answer key. Okay, I did something wrong. Our answer should be negative 4, negative 4. Let's try it again. Let's see. So starting from 4/9, something went wrong. Let me go back to the previous step. Negative 9x is equal to negative 4. Okay, well I did that part right, but something else went wrong. So let me see. Let me go back to the very first line here. So, this is what I'm talking about. Negative 9x plus 5 times negative 4 is equal to 16. Negative 9x plus 20. There we go. Did you find it? Do you see it? This right here is my mistake. Because 5 times negative 4 is not 20, it's negative 20. So I need to change that. There we go. And then that's going to change this work that I did here. So I'm going to add 20 to both sides. So I get, there we go, this is looking much better. And then my final answer, x is equal to negative 4. And there we go. So there you have it. So with a problem like number 11, you definitely can change the coefficients. You can change them by either multiplying or dividing, so that way you get a set of variables that you can eliminate. Okay. In this case, we got rid of the x's because I could change negative 3 into a positive 9. Okay, so there you go. So that's number 11. Let's take a look at number 23. Okay, so this looks interesting because everything's kind of scrambled, and not everything is lining up very well, right? You'll notice in the first equation there is a y variable and an x variable on the right side, whereas in the second equation the x is on the right side and the y is on the left side, and the constant is on the left side as well. It's a mess right now. So let's see if we can rearrange some of this. Okay, I'm going to work up here, so don't mind this 21 here. I just want to rewrite these things in standard form. That way I have something nice and neat to work with. So what's nice about this first equation is I can just flip it. I can rewrite it. I can just rewrite it with the equal sign on the right side. So I can say negative 7x minus 20y is equal to negative 14. And there I have something in standard form. So that was nice and easy to work with. Now let's take a look at the second equation. 10y plus 4 is equal to 2x. In this case, I'm going to have to either move I need to move this 2x over here, and then I need to move my 4 over here. That's 2 steps. Is there a way for me to do it in one step? Oh yeah, I could just move my y value, or my y variable and coefficient, over to the right side, and then just flip it. Perfect. I'll just do that. So again, what I'm doing here is I'm just rewriting my equations so that they're a little easier to work with. So when I do this, these cancel out. I'm left with 4 is equal to 2x minus 10y. And if I wanted if I want the orientations to match where my equal sign is on the right side, I can just rewrite it like this. 2x minus 10y is equal to 4. And now I have my two equations. So let me rewrite them in a place that's easier to read. So I'll cross out these problems here. Hopefully this is okay. Hopefully you can read this. So my two equations now. Negative 7x minus 20y is equal to negative 14. And then I have my second equation, 2x minus 10y is equal to 4. Okay, so now that we have my variables lined up, my x's are lined up with x's, my y's are lined up with y's, it doesn't look like any of my coefficients are matching here for me to eliminate them. So I'm going to have to change one of them. And immediately my eye goes to this negative 10y. Can I easily change that 10 into a 20? Yes, I can. How do I do that? By multiplying by 2. So what I'm going to do is I'm going to multiply both sides of that equation only by 2. I'm going to multiply this by 2. Actually, it's already negative, and I need it to be positive in order to eliminate. So I'm going to multiply it by negative 2. And then I have to do the same thing to the right side of my equation. So I get something like this, negative 4x plus 20y, right, because negative 2 times negative 10, right, distributing here, is equal to 4 times negative 2 is negative 8. Okay, whew, that was a little bit of a long process to get to this, but so far so good. So now I have my two equations. Let me rewrite it once more. 20y is equal to negative 14. Negative 4x plus 20y is equal to negative 8. Whew, and there we go. That was a doozy, wasn't it? But take a look. Now I have my opposite coefficients, and those will easily cancel out. So now I can just add the left sides of my equations together and the right sides of my equations together. Let's go ahead and do it. Negative 7x plus negative 4x is negative 11x. These guys cancel each other out. And then I'm left with, on the right side, negative 14 plus negative 8 is negative 22. Solve for x by dividing by negative 11 on both sides. And so x is equal to positive 2. Okay, now what we can do is we just take this value, plug it into one of the equations for x. So I'm going to plug it into this bottom equation here. So 10y plus 4 is equal to 2x. I'm going to change colors here to signify that I'm doing a new step. So 10y plus 4 is equal to 2x, or 2 times x, which we'll replace with a 2, because that's what we said x is equal to. So 10y plus 4 is equal to 2 times 2, which is 4. I solve for y, so I'm going to subtract 4 from both sides. 10y is equal to 0. I can still solve this, guys. Divide both sides by 10. Y is equal to 0. So it looks like my solution to this problem is 2, 0. Let's double check the answer key here. Number 23. There we go. 2, 0. Excellent. Okay. So those are the two examples that I wanted to walk through here. They are definitely more involved. They have more steps required to reach the correct answer. Okay? So hopefully this helps with the elimination part. Let's move on to graphing. With graphing, really the tricky ones I felt I needed to review with you guys were number 4 and number 7. The reason for number 4 is because of this first line here. We didn't really get to talk too much about horizontal and vertical lines, but this first equation here is going to be, well, it says y is equal to negative 1. And the way I think about it, I don't see an x here. There's not really going to be any change in our y value. So how I read it, or how I interpret it as, I say that for every x value, no matter what I plug into this top equation, y is always going to equal negative 1. So if I plug in 1 for x, I get negative 1 for y. If I plug in 0 for x, and in this case there's still no 0, there's still no x here, right? So y is always equal to -1. And you'll realize soon enough that, hey, you're just creating a horizontal line. So just draw a line like this. And this is my line y equals -1. So whenever you see an equation of a line that says y equals a number, you'll know that it's going to be a horizontal line. Now let's go ahead and graph this second line here. Y equals -5/2 x plus 4. Immediately, I am saying, hey, this is my y-intercept, and then this right here is my slope. Thank you, slope-intercept form. You're great. You're amazing because you're so easy to interpret. So starting with my y-intercept there, I'm going to treat my slope as -5/2. Okay, so I'm going to go down 5 units and then to the right 5 units. So let's go ahead and do that. 1, 2, 3, 4, 5, and then over 2, 1, 2. There we go. And I think that's all I can fit, really. Not quite. Let's see if I can move this. No, that's not what I want. Okay, let's just start over. No, it must go through both points. There we go, that's much better. Alright, and this is my line y equals -5/2 x plus 4. And remember, we're just looking for that point of intersection. Where do the two lines cross each other? And in this case, our answer is at the point 2, -1. And there you go. Alright, and then second question I would like to do is number 7. And this is just practicing those negative slopes. So my y-intercept is at -2, and my slope is -1/2. I'm going to treat this as -1/2, so I'm going to go down 1 and to the right 2 units. So down 1 to the right 2 units, down 1 to the right 2 units, and then you can actually go backwards as well. So instead of moving down 1, I'm going to go up 1, and instead of moving right 2, I'm going to move to the left 2. There we go, up 1 to the left 2, and there we have a line. Boom. Just going to label it for good measure, -1/2 x minus 2. Alright. Then I have y is equal to -3/2 x plus 2, so I'm going to start at +2, and I'm going to treat this as -3/2, so I'm going to go down 3 and to the right 2. 1, 2, 3 over 2. 1, 2, 3 over 2. I can also go backwards, go up 3, 1, 2, 3, and to the left 2. Let's see if I can get... Thank you, technology. And there we go. So it looks like my solution is right there, and that is the point 4, -4. And there you have it. Isn't that fascinating? Just finding the solutions. Oh, you guys might notice that sometimes the lines don't intersect. That's okay. Sometimes the lines are the same line, and that's okay as well. So like if you have two parallel lines, right? If you have lines that never intersect, they do not touch each other, we say that there's no solution, because, right, a solution with a system of equations is where the lines intersect, but they don't, right? So you have that option, or you have the option of infinitely many solutions. Infinitely many solutions. And this happens when the lines are exactly the same. The lines lie exactly on top of each other, and so therefore every point along that line satisfies both equations. So if you come up with those two answers, that's okay. You're not incorrect. Oh no, my iPad's dying. Okay, let's move on to the last section here. Solving by substitution. Oh yeah, see, look at this. For number 6, you guys have lines that do not intersect at all, so they say that there's no solution. And then if you have, let's see if they have an infinitely many. Oh, no, they don't. Okay. But maybe later. It can happen. Okay. And then for substitution, I wanted to go over two problems. There's number 7 and number 11. You guys may have noticed that a lot of the problems, especially at the beginning of the worksheet, one equation was given in slope-intercept form, or y equals mx plus b form, right? And then the other one was given in standard. And that led to an easy substitution process, right? But that is not always going to be the case, okay? Which is why I picked these two examples. Number 7 and number 11 both present their equations in standard form. Okay, so I'm going to show you the process of how to rewrite one equation so that way you can use substitution to your advantage. So let's take a look. Now, generally, you want to find the variable that doesn't have a coefficient. In this case, y looks like a really good candidate to rewrite the equation for. And typically you want the positive y value. Not to say that the negative y value can't be used, but it's just going to add an extra step. But for simplicity's sake, I'm going to use the positive y. Okay, so I'm going to show my work up here. So negative 4x plus y is equal to 6. Now I can rewrite this so that way I'm only left with y over here. So all I need to do is move this negative 4x. And the way that I do that is I just add it to both sides of my equations. Or of my equation, excuse me. And so these end up canceling out, so I'm just left with y here. And then on the right side, I cannot combine 6 and 4x, so I'm just going to leave them separate. So I could just say 4x plus 6. And now I've rewritten my problem. So I can forget this for now, and then I'm going to rewrite it. Y is equal to 4x plus 6. And now that I know what y is equal to, I can go ahead and plug it in. I can plug in this value for y. And that's what substitution is all about. So let's go ahead and do that. So I have negative 5x minus y. So I'm going to take this 4x plus 6 and write it in parentheses. Right, because this value was y. So I'm just substituting it in, and that is equal to 21. Okay, with this, remember there's like this invisible 1 there. So really, when you have the minus sign right outside the parentheses, you have to distribute a negative 1 to both terms inside. So negative 1 times 4 is negative 4x. Negative 1 times 4x is negative 4x. Negative 1 times positive 6 is negative 6. And now I can just rewrite everything else that's left. Let's combine like terms. Negative 5x minus 4x. This is negative 9x. Minus 6 is equal to 21. Let's keep solving. Add 6 to both sides. Negative 9x is equal to 27. Keep solving. We divide by negative 9 on both sides. And then x is finally equal to negative 3. Now, what do you think we're going to do with this value? That's right, you guessed it. We're going to take it and we're going to plug it in to this equation. Because if you plug in x to this equation, it'll spit out a y value. Okay, so let's go ahead and do that. Use a different color here. Let's use green. Okay, so y is equal to 4 times x, and we know x is equal to negative 3 plus 6. So that's negative 12 plus 6, which is equal to negative 6. So it looks like my answer is going to be negative 3, negative 6. Let's check our work here. Negative 3, negative 6 for number 7. Perfect. So negative 3, negative 6 is our final answer. There you go. Okay. So now you see how I rearranged one equation so that it was conducive for solving by substitution. Okay. You might be asking, oh, Mr. RG, do we always have to do the y is equal to? And to that I say, no, of course not. You can also say x is equal to something, which is what I'm going to show you in problem number 11. Okay. So, like I said before, it's it'll be much easier to rewrite the equation that has a single variable by itself, right? You'll notice that in the bottom equation there's a negative 3x and a negative 3y. Not going to be the easiest to change, so find the equation with a single variable by itself, which would be this x. This 3y, I'm going to move it, so I'm going to rewrite it. Let's go ahead and do that. So x plus 3y is equal to 1. In order to get this x by itself, I'm just going to rewrite my equation by subtracting 3y from both sides. These cancel out. All I'm left with is x on the left side, and then I have negative 3y plus 1, or if you want to write 1 minus 3y, that is okay too. Let's stick with that. I think that'll be less confusing. 1 minus 3y. And there we have our new and improved equation ready to be substituted, right? So I'm going to ignore this top equation, and I'm going to plug in this value for x right there. Okay, so let's take a look at what that looks like. So I have negative 3 times x, and I know that x is equal to the value of, or the quantity of 1 minus 3y. And then I fill in the rest of my equation, right? So this is x minus 3y is equal to negative 15. And now I can go ahead and solve for the y, for the variable for y, okay? So let's go ahead and distribute this negative 3. So negative 3 times 1 is negative 3. Negative 3 times negative 3y is positive 9y. And then I just fill in the rest. Minus 3y is equal to negative 15. Let's combine like terms. You can combine 9y and negative 3y. That's negative, what am I talking about? That's positive 6y. And then I can bring down that negative 3, and that is equal to negative 15. Let's keep going. Add 3 to both sides. 6y is equal to negative 12. If I continue my work over here, divide both sides by 6, and y is equal to negative 2. Now, that's only half of my answer here. I also need an x value to go with it. So I'm going to take this answer that I got for y and plug it into this equation. Let's go ahead and switch back to green here. So I know that x is equal to 1 minus 3 times y, and I know that y is equal to negative 2, so I'm going to multiply 1 minus 3 times negative 2, so that's 1 minus negative 6, which is the same thing as 1 plus 6, which is 7. So x is equal to 7. So my final answer looks like it's going to be 7 comma negative 2. Let's double check. Number 11, 7 negative 2. There we go. We are good. Alright, you guys. I hope this video helped. Please let me know if you have any other questions regarding solving systems of equations. Alright? Have a great weekend, and I will talk to you guys later.